We're having a debate. Debate is over the proposition, what the world needs now is nuclear energy. True or false? And before we have the debate, I'd like to actually take a show of hands. On balance right now, are you for or against this? So those who are yes, raise your hand. For. Okay, hands down. Those who are against, raise your hands. Okay, I'm reading that at about 75-25 in favor at the start, which means, you know, we're going to take a vote at the end and see how that shifts, if at all. So here's the format. They're going to have 6 minutes each, and then after one little quick exchange between them, I want 2 people on each side of this debate in the audience to have 30 seconds to make one short, crisp, pungent, powerful point. So in favor of the proposition, possibly shockingly, is one of truly the founders of the environmental movement, a long-standing TEDster, the founder of the Whole Earth Catalog, someone we all know and love, Stewart Brand.
Whoa. The saying is that with climate, those who know the most are the most worried. With nuclear, those who know the most are the least worried. A classic example is James Hansen, the NASA climatologist pushing for 350 parts per million carbon dioxide in the atmosphere, came out with a wonderful book recently called Storms of My Grandchildren. And Hansen is hard over for nuclear power, as are most climatologists who are engaging this issue seriously. This is the design situation, a planet that is facing climate change and is now half urban. Look at the client base for this. 5 out of 6 of us live in the developing world. We are moving to cities, we are moving up in the world, and we are educating our kids, having fewer kids, basically good news all around. But we move to cities toward the bright lights, and one of the things that is there that we want, besides jobs, is electricity. And if it isn't easily gotten, we'll go ahead and steal it. This is one of the most desired things by poor people all over the world, in the cities and in the countryside. Electricity for cities, at its best, is what's called baseload electricity. That's where it is on all the time. And so far, there are only 3 major sources of that: coal and gas, hydroelectric, which in most places is maxed out, and nuclear. I would love to have something in the 4th place here, but in terms of constant, clean, scalable energy, nuclear and wind and the other renewables aren't there yet because they're inconstant. Nuclear is and has been for 40 years. Now, from an environmentalist standpoint, the main thing you want to look at is what happens to the waste from nuclear and from coal, the 2 major sources of electricity. If all of your electricity in your lifetime came from nuclear, the waste from that lifetime of electricity would go in a Coke can, pretty heavy Coke can, about 2 pounds. But 1 day of coal adds up to one hell of a lot of carbon dioxide at a normal 1 gigawatt coal-fired plant. Then what happens to the waste? The nuclear waste typically goes into a dry cask storage out back of the parking lot at the reactor site, because most places don't have underground storage yet, just as well, because it can stay where it is. But all the carbon dioxide, vast quantities of it, gigatons, goes into the atmosphere where we can't get it back yet, and where it is causing the problems that we're most concerned about. So when you add up the greenhouse gases in the lifetime of these various energy sources, nuclear is down there with wind and hydro, below solar, and way below, obviously, all the fossil fuels. Wind is wonderful. I love wind. I love being around these big wind generators. But one of the things we're discovering is that wind, like solar, is an actually relatively dilute source of energy. And so it takes a very large footprint on the land, a very large footprint in terms of materials, 5 to 10 times what you use for nuclear. And typically, to get 1 gigawatt of electricity is on the order of 250 square miles of wind farm. In places like Denmark and Germany, they've maxed out on wind already. They've run out of good sites. The power lines are getting overloaded, and you peak out. Likewise with solar, especially here in California, we're discovering that the 80 solar farm schemes that are going forward want to basically bulldoze 1,000 square miles of Southern California desert. Well, as an environmentalist, we would rather that didn't happen. It's okay on frapped out agricultural land. Solar is wonderful on rooftops. But out in the landscape, 1 gigawatt is on the order of 50 square miles of bulldozed desert. When you add all these things up, Saul Griffith did the numbers and figured out what it would take to get 13 clean terawatts of energy from wind, solar, and biofuels. And that area would be roughly the size of the United States, an area he refers to as Renewistan. The guy who's added it up all this very well is David Mackay, physicist in England, and in his wonderful book, Sustainable Energy, among other things, he says, I'm not trying to be pro-nuclear, I'm just pro-arithmetic. In terms of weapons, the best disarmament tool so far is nuclear energy. We have been taking down the Russian warheads, turning it into electricity. 10% of American electricity comes from decommissioned warheads. We haven't even started on the American stockpile. I think of most interest to a TED audience would be a new generation of reactors that are very small, down around 10 to 125 megawatts. This is one from Toshiba. Here's one the Russians are already building, floats on a barge, and that will be very interesting in the developing world. Typically, these things are put in the ground. They're referred to as nuclear batteries. They're incredibly safe, weapons proliferation proof, and the rest of it. Here's a commercial version from New Mexico called the Hyperion, and another one from Oregon called NuScale. Babcock and Wilcox, who make nuclear reactors. Here's an integral fast reactor. Thorium reactor, the nation Murvolt's involved in. The governments of the world are going to have to decide that coal is need to be made expensive, and these will go ahead. And here's the future.
Okay. So arguing against a man who's been at the nitty-gritty heart of the energy debate, the climate change debate for years. In 2000, he discovered that soot was probably the second leading cause of global warming after CO2. His team have been making detailed calculations of the relative impacts of different energy sources. His first time at TED, possibly a disadvantage, we shall see. From Stanford, Professor Mark Jacobson. Good luck.
Thank you. Okay. So my premise here is that nuclear energy puts out more carbon dioxide, puts out more air pollutants, enhances mortality more, and takes longer to put up than real renewable energy systems, namely wind, solar, geothermal power, hydro, tidal, wave power. And it also enhances nuclear weapons proliferation. So let's start by just looking at the CO2 emissions from the life cycle. CO2e emissions are equivalent emissions of all the greenhouse gases and particles that cause warming and converted to CO2. And if you look, wind and concentrated solar have the lowest CO2 emissions. If you look at the graph, nuclear, there are two bars here. One is a low estimate and one is a high estimate. The low estimate is the nuclear energy industry estimate of nuclear. The high is the average of 103 scientific peer-reviewed studies. And this is just the CO2 from the life cycle. If we look at the delays, it takes between 10 and 19 years to put up a nuclear power plant from planning to operation. This includes about 3.5 to 6 years for a site permit, and another 2.5 to 4 years for a construction permit and issue, and then 4 to 9 years for actual construction. And in China, right now they're putting out 5 gigawatts of nuclear, and it's the average just for the construction time of these is 7.1 years, on top of the planning times. While you're waiting around for your nuclear, you have to run the regular electric power grid, which is mostly coal in the United States and around the world. And the chart here shows the difference between the emissions from the regular grid, resulting if you use nuclear or anything else, versus wind, CSP, or photovoltaics. Wind takes about 2 to 5 years on average, same as concentrated solar and photovoltaic. So the difference is the opportunity cost of using nuclear versus wind or something else. So if you add these two together alone, you can see a separation that nuclear puts out at least 9 to 17 times more CO2 equivalent emissions than wind energy. And this doesn't even account for the footprint on the ground. if you look at the air pollution health effects, this is the number of deaths per year in 2020 just from vehicle exhaust. Let's say we converted all the vehicles in the United States to battery electric vehicles, hydrogen fuel cell vehicles, or flex fuel vehicles run on E85. Well, right now in the United States, 50 to 100,000 people die per year from air pollution, and vehicles are about 25,000 of those. In 2020, the number will go down to 15,000 due to improvements. And so on the right, you see gasoline emissions, the death rates in 2020. If you go to corn or cellulosic ethanol, you'd actually increase the death rate slightly. If you go to nuclear, you do get a big reduction, but it's not as much as with wind or concentrated solar. Now, if you consider the fact that nuclear weapons proliferation is associated with nuclear energy proliferation, and because we know, for example, India and Pakistan developed nuclear weapons secretly by enriching uranium in nuclear energy facilities. North Korea did that to some extent. Iran is doing that right now, and Venezuela would be doing it if they started with their nuclear energy facilities. If you consider just in the next 30 years, if you did a large-scale expansion of nuclear energy across the world, and as a result, there was just one nuclear bomb created that was used to destroy a city, such as Mumbai or some other big city, mega city, the additional death rates due to this averaged over 30 years and then scaled to the population of the US would be this. So do we need this? The next thing is, what about the footprint? Stewart mentioned the footprint. Actually, the footprint on the ground for wind is by far the smallest of any energy source in the world. Because the footprint, as you can see, is just the pole touching the ground. And you can power the entire US vehicle fleet with 73,000 to 145,000 5-megawatt wind turbines. That would take between 1 and 3 square kilometers of footprint on the ground entirely. The spacing is something else. That's the footprint that is always being confused. People confuse footprint with spacing. As you can see from these pictures, the spacing between can be used for multiple purposes, including agricultural land, rangeland, or open space. Over the ocean, it's not even land. Now, if we look at nuclear, with nuclear, what do we have? We have facilities around there. You also have a buffer zone that's 17 square kilometers, and you have these uranium mining that you have to deal with. Now, if we go to the area, a lot is worse than nuclear or wind. For example, cellulosic ethanol, to power the entire US vehicle fleet, this is how much land you would need. That's cellulosic, second generation biofuels from prairie grass. Here's corn ethanol. It's smaller. This is based on ranges from data. But if you look at nuclear, it would be the size of Rhode Island to power the US vehicle fleet. For wind, there's a larger area, but much smaller footprint. And of course, with wind, you could put it all over the East Coast, offshore, theoretically, or you can split it up. And now, if you go back to looking at geothermal, it's even smaller than both, and solar is slightly larger than the nuclear spacing, but it's still pretty small. And this is to power the entire US vehicle fleet. To power the entire world with 50% wind, you would need about 1% of world land. Matching, the reliability. Baseload is actually irrelevant. We want to match the hour-by-hour power supply. You can do that by combining renewables. This is from real data in California, looking at wind data and solar data, and it considers just using existing hydro to match the hour-by-hour power demand. Here are the world wind resources. There are 5 to 10 times more wind available worldwide than we need for all the world. So then here's the final ranking, and one last slide I just want to show. This is the choice. You can either have wind or nuclear. If you use wind, and you guarantee ice will last. Nuclear, the time lag alone will allow the Arctic to melt and other places to melt more, and we can guarantee a clean blue sky or an uncertain future with nuclear power.
Come, Stewart. Come. No, stay here. All right. So while they're having their comebacks on each other, and yours is slightly shorter because you slightly overran, I need 2 people from either side. So if you're for this, if you're for nuclear power, put up 2 hands. If you're against, put up 1. And I want 2 of each for the mics. Now then, you guys have a minute comeback on him to pick up a point he said, challenge it, whatever.
I think a point of difference we're having, Mark, has to do with weapons and energy. These diagrams that show that nuclear somehow is putting out a lot of greenhouse gases, a lot of those studies include, well, of course, war will be inevitable, and therefore we'll have cities burning and stuff like that, which is kind of finessing it a little bit, I think. The reality is that there's, 21 nations that have nuclear power. Of those, 7 have nuclear weapons. In every case, they got the weapons before they got the nuclear power. There are 2 nations, North Korea and Israel, that have nuclear weapons and don't have nuclear power at all. The places that we would most like to have really clean energy occur are China, India, Europe, North America, all of which have sorted out their situation in relation to nuclear weapons. So that leaves a couple of places like Iran, maybe Venezuela, that you would like to have very close surveillance of anything that goes on with fissile stuff. Pushing ahead with nuclear power will mean we really know where all of the fissile material is, and we can move toward 0 weapons left once we know all that.
Mark, 30 seconds either on that or on anything Stewart said.
Well, we know India and Pakistan had nuclear energy first, and then they developed nuclear weapons secretly in the factories. And the other thing is, we don't need nuclear energy. There's plenty of solar and wind. You can make it reliable, as I showed with that diagram. That's from real data, and this is an ongoing research. This is not rocket science. Solving the world's problems can be done if you really put your mind to it and use clean, renewable energy. There's absolutely no need for nuclear power.
I need someone for.
Thank you, Chris. I'm Rod Beckstrom, CEO of ICANN. I've been involved in global warming policy since 1994 when I joined the Board of Environmental Defense Fund that was one of the crafters of the Kyoto Protocol. And I want to support Stewart Brand's position. I've come around the last 10 years. I used to be against nuclear power. I'm now supporting Stewart's position softly from a risk management standpoint, agreeing that the risk of overheating the planet outweighs the risk of a nuclear incident, which certainly is possible and is a very real problem. However, I think there may be a win-win solution here where both parties can win this debate, okay? And that is, we face a situation where it's carbon caps on this planet or die. And in the United States Senate, we need bipartisan support. Only 1 or 2 votes are needed to move global warming through the Senate, and this room can help. So if we get that through, the market will solve these problems. Thanks, Chris.
Thank you, Rod Beckstrom. Against.
Hi, I'm David Fenton. I just want to say a couple quick things. The first is, be aware of the propaganda. The propaganda from the industry has been very, very strong, and we have not had the other side of the argument fully aired so that people can draw their own conclusions. Be very aware of the propaganda. Secondly, think about this. If we build all these nuclear power plants, all that waste is going to be on hundreds, if not thousands, of trucks and trains moving through this country every day. Tell me they're not going to have accidents. Tell me that those accidents aren't going to put material into the environment that is poisonous for hundreds of thousands of years, and then tell me that each and every one of those trucks and trains isn't a potential terrorist target.
Thank you. 4. Anyone else for? Go.
Hi, I'm Alex. I just wanted to say I'm, first of all, the renewable energy's biggest fan. I've got solar PV on my roof. I've got a hydro conversion at a water mill that I own, and I'm very much pro that kind of stuff. However, there's a basic arithmetic problem here. The capability of the sun shining, the wind blowing, and the rain falling simply isn't enough to add up. So if we want to keep the lights on, we actually need a solution which is going to keep generating all of the time. I campaigned against nuclear weapons in the 80s, and I continue to do so now. But we've got an opportunity to recycle them into something more useful that enables us to get energy all of the time. And ultimately, the arithmetic problem isn't going to go away. We're not going to get enough energy from renewables alone. We need a solution that generates all the time. If we want to keep the lights on, nuclear is that solution.
Thank you. Anyone else against?
The last person who's in favor made the premise that we don't have enough alternative renewable resources, and our against proponent up here made it very clear that we actually do. And so the fallacy that we need this resource and we can actually make it in a time frame that is meaningful is not possible. I will also add one other thing. Ray Kurzweil and all the other talks, we know that the stick is going up exponentially. So you can't look at state-of-the-art technologies and renewables and say, that's all we have, because 5 years from now, it will blow you away what we will actually have as alternatives to this horrible, disastrous nuclear power.
Point well made. Thank you. So, So each of you has really just a couple sentences, 30 seconds each, to sum up your final pitch.
I loved your it all balances out chart that you had there. It was a sunny day and a windy night. And just now in England, they had a cold spell. All of the wind in the entire country shut down for a week. None of those things were stirring. And they, as usual, had to buy nuclear power from France. 2 gigawatts comes through the tunnel. This keeps happening. The point on I used to worry about the 10,000-year factor. And the fact is, we're going to use the nuclear waste we have for fuel in the 4th generation reactors that are coming along. And especially the small reactors need to go forward. I heard from Nathan Myhrvold, and I think here's the action point. It'll take an act of Congress to make the Nuclear Regulatory Commission start moving quickly on these small reactors, which we need very much here and in the world.
So we've analyzed the hour-by-hour power demand and supply, looking at solar, wind, using data for California, and you can match that demand hour by hour for the whole year almost. Now, with regard to the resources, we've developed the first wind map of the world from data alone at 80 meters. We know what the wind resources are. You can cover 15%. Only 15% of the entire US has wind at fast enough speeds to be cost competitive, and there's much more solar than there is wind. There's plenty of resource. You can make it reliable.
Okay, so, thank you, Mark. So if you were in Palm Springs, shameless. So, people of the TED community, I put it to you, what the world needs now is nuclear energy. All those in favor, raise your hands. And all those against? Whoa. Now that is my take on that. Just put up, hands up, people who changed their minds during the debate, who voted differently. Those of you who changed your mind in favor of 4, put your hands up. Okay, so here's the read on it. Both people won supporters, but on my count, the mood of the TED community shifted from about 75-25 to about 65-35. In favor. In favor. You both won. I congratulate both of you. Thank you for the... Great job. Thank you, sir.